let's see. I'm gonna connect to Code Planet and I'm gonna attach my screen. And I think we used 250 the last time. Yeah, we were dealing with this terminal stuff. That's right. So let's see. I will start by going into the correct directory and see if I can find this one. I think it's FSE2. Yes. And I right click and I choose Open in Editor. And what this does is it will simply download all the files and subdirectories, and when we update anything locally, it will automatically sync that against server. So basically we are coding remotely against this server. So let's see if I can fit this window inside over here. So let's pull it out here, and that will be good, I think. Perhaps I should make the text a little bit smaller. I hope you're not having any trouble on small screens to watch that text. Alright, so let's see what we did last time. We were coding this decryptor tool. We created the H file with some pretty basic stuff, basically the same things that I pretty much always start with a project, and then basically the same here. What we did was we defined the different steps that we are going through in pseudocode. So first we want to read the key from the standard input, and we want to read it in a way that it doesn't echo to the screen. Then we want to initialize the encryption. We want to decrypt the first 16 bits of the file, and those 16 bits contains a number between 0 and 65,535, and that basically says if it's let's say 600, then it will skip the next 600 bytes. So it's a padding mechanism in order to make this hash a little bit harder to find. Because if we just put the hash in a fixed location, then anyone can find it and possibly crack it. But if we conceal the location, so it can be anywhere inside of over 60,000 bytes, that means that if they want to crack this hash, they need to crack 60,000 hashes, not one. So that's why. And one important thing is that this padding is truly random, and that the hash also looks like random bytes. So it should be indistinguishable from each other. Then we verify the hash against the key that we read from the standard in. If it's the right key, we will start decrypting. Otherwise, we will simply throw an error. And then we decrypt the rest of the file and save it to the out file. Pretty basic setup. Alright, so we were having a little bit of trouble with this disabling the echo step. What I did was I took this structure from my assembly code, because I wrote a similar function in assembly not long ago. So I thought perhaps we could use that. So let's turn this assembly structure into a regular C structure simply by renaming these commands to int32 and removing the dots. We should also remove the things to the right. And let's see, CCC, this is not, those two last is not in 32, they are in 8. So int 8. And now we can remove this stuff. And we also need to change this up a little bit so it matches the C syntax of a structure. So let's call this struct terminals. And let's do something like this. Alright, so now we have the actual struct. That's step 1, so to speak. The next thing is basically that we need to use the IOCTL command in order to turn off this echo. So if we go to our terminal and we do, let me just check that this terminal is visible. I will move it a little bit and perhaps shrink it as well, something like, we don't have to see all. This is good, I think. Alright, so what we do is we do man IOCTL terminal, or not terminal, maybe just term or TTY perhaps. Yes, here it is. Okay, so these are the, because this IOCTL syscall is being used for a lot of different IO instructions or operations. So we need to find the right one. And what we want to do is, let's see if there's an example, if we're lucky. Okay, win size. There's a lot of stuff in here. Alright, so maybe I can peek a little bit at my old code. I don't like copy pasting code, but since it's my own, I think it's, as an exception, I think it's pretty okay. So let's see, let's create a new window and let's go to code and find some, and let's see, so we go to the encryptor. There's all of these different M's. If you don't know what this is basically the Windows version of a new line. So that's what this editor that I'm using, VS Code, it always appends those, but they are quite annoying when dealing with Linux. So what you can do is you run the call command, and then you take an input and you output it to something, let's say ABC inside a temp, and now we should have gotten rid of those stuff. Good. Alright, so let's see. Here we have echo. I think this will do. So let's do this instead. So we can remove this one. It becomes too complicated in this case, I think. So let's see. We have a change echo function here, but let's use the one that I know works, or at least I hope it works. So we have bool echo bool on. Let's go into the H file and update our signature. So this is just echo, right? Yeah, echo, and it's a bool, and it takes a bool, right? And we probably need some kind of include as well. Let's check that out. So code file send fse dot h. No, what's it called then? File send dot h. And this is the one we need, I think. Okay, so let's put it right there. Alright, we had it already. And we save, and let's check this out. So echo, and if we turn it on or if we turn it off, and then we have this read key thing, and it calls change echo. So instead it'll call echo and echo. Let's see if this works. So let's see, read key is right. Let's compile. So we run make clean, jump down a little bit, we clear the screen, and we run make. Okay, not too many warnings actually, and only those set but not used. But let's see if this works. So we run fst, need to give it some bogus arguments. Key, okay, that's not entirely what I wanted. Why does that happen? Did it update correctly if we do fsd.c bool echo? So what does it do? It creates one of those termios things. It calls on this tcget attribute, cl flag. If we are giving it a true value for the on, then we will activate the echo flag. Otherwise, we will, let's see, we will AND it with the inverse of echo. So the echo part of it will be zeros. That's right. That should work. But something seems to be a little bit off. I wonder if it's really supposed to be CL flag. I'm not too sure that it should actually, because we have a whole lot of these. So if you do man terminals, let's see if it shows us the structure here. So we have 4 of those, and I always seem to forget which one it is. Perhaps we should just go through them one at a time. So we have IOCL. Let's see. We are using L here. And what did we have? IO. Yeah, I. So let's start with I. I don't think it's I, but let's just go through them all. See if that is the problem. Like so. Then we compile, and we run. Nope, that's not it. What else did we have? We have O and then C. So we change this to O, we change this to O, and we change this to O. Save. There is some logic behind this, but I'm not too sure what it is. It can be either way, actually, that we are dealing with input or we are dealing with output, because we're dealing with both, and it depends on what perspective you are watching this from. Alright, so let's see. What are we going to do? The next thing we're gonna try out is, let's scroll up a little bit. So we had I and we had O, and now it's C. So we do C, and we do C, and we do C. We save. And we run make, and we run this, and I don't really like this actually. Wonder if something else is wrong with this code. But let's try the last one anyways. And that is L. I don't remember what we had when we started out actually. We probably tried something twice. Compile, and we run. That looked a little bit weird. Perhaps we should reset the terminal. Right. Okay, so now it works. Did you see that? It asked for the key. When I type something, we don't see anything, but it saves it to the buffer. Okay, that's pretty awesome. So now we are on the track. Let me just check one thing real quick. We don't seem to have a whole lot of activity here. Wonder if I did something wrong. But perhaps not. Never mind. It's probably because of all of those errors. Can't pronounce that word, but all of these bad stream attempts that failed. Okay, so let's keep on add it for a while longer. So let's see. I need to. Okay, the first thing was reading the key, which we have successfully done. We're ready to TMP, but we can read it to something more permanent. So let's just call this key, and we will change this to key, and read key is done. Next thing is to initialize decryptor, and if we haven't done that already, we need to add my encryption library to this H file, and it's called arc4.h in this case. So let's see. The first thing is we need to create an arc4 object. Let's do that, and it's called arc4 like this, and we can name it sorry, we can name it A for arc4 then, or perhaps something better is state, right? So when we have initialized key, we will initialize the decryptor. And we do that by calling the function arc4 init, and it takes two arguments. It takes the key and the key length. So we need one more variable, and let's make this an int16, and we call it size. And after we have read this key, we don't need to echo it to the screen. But what we do want to do is calculate its length. So let's just do something like, size equals, we need to cast this to a regular, no, not a regular, we need to cast it to int16. Then we call string length, and inside of it we cast it to a regular char. And then we have the length of the string. Let's also assert that the size is not 0. And now we can just pass the key and the size, like so. And we can assert that we got something back. Okay, so now we can cross this off. That wasn't really time consuming, right? So let's do one more of those today, and then we'll call it a night. And the next thing is we need to decrypt the first 2 bytes of the file. So we need to open the file to begin with, and let's store the FDs here in the file descriptors here in the main. So we will do something like, let's call them in, out. And we're gonna set the in file equal to the what did I make those? make those int32 instead to be to follow the same standard, which means we need to cast this to int32. Then we call open, and we open our, where do we have it? Our source file. And the source file we will open with the O read only flag. And let's assert that in is greater than 0. Let's also open the out file. So we will do the int32 representation of the open call, and we will the same way open the destination file, but in this case we will open it as write only, and we want to create the file if it doesn't exist and truncate if it does exist. What mode do we want? Let's make this 600. Since we are decrypting a file, there's probably something important with it, right? Something secret. So we don't want to have this readable to the whole world. So let's also assert that out is greater than 0. And now we have our file descriptors. With them and our initialized encryption, what we can do is we can define another int16. Let's call this what should we call this? Let's call it magic. It's not entirely accurate, but it works. So magic will be equal to our own function, which we haven't defined yet, and let's call it something like grab magic, and we will send our arc4 state. We will send our in file descriptor. At this point we don't need to send our out descriptor. And let's see, we should assert, I think, that magic is greater than 0. I'm not 100% sure though, so let's check the encryptor code and see which possibilities there are. So read key and pad size is equal to pad size 8 secure rand. Let's see, and where do we have this secure rand? Here. And what kind of data do we get? Seems like we do get 2 explicitly random bytes. So they can be 0, they can be 255, each one of those bytes. Okay, so no assertion, because we can't really fail with this operation unless the file is, if we can't read the file, if there's some kind of IO error or something. But in that case we can basically abort from that function instead. So this is what we want to do. We want to grab this magic. And how do we do that? Well, let's see how we deal with that. If we create the function to begin with, it will be an int16. We will call it grab magic, and we send our arc4 state, and we send our int32 file descriptor. And before I forget, let's also update the H file. So let's see, usage read key main. Let's just add it right here. And what did we say? We said that in 16 grab magic, and it took 2 arguments, right? One arc4 pointer and one int32. That's right. And this is a pretty basic function. All we need to do is read those 2 bytes and interpret them correctly. So let's create a variable which we call ret, because we're going to return it, and it's an int16. We do also need some kind of buffer, and it doesn't have to be big, so let's just do 8 bytes. It shouldn't be int, by the way. Let's make this int 8. And we will 0 that buffer. And then we will call, let's see, let's create one regular int in this case, which we will call n, just to handle the return value, because my integers are always unsigned, and we might want to look at the signedness. So we 0 that, and then we will set n equal to read, and we want to read from the file descriptor, but we need to cast it to a regular int, so fd. Then we have the buffer, which we need to cast into a regular char pointer, buff. And then we have the maximum size, which is 7. And no, we just want to read 2 bytes. That's right. So if everything succeeded, then we can assert that n is equal to 2. Otherwise, we quit. So now we have successfully read this into this char buffer. Now we need to make a 16-bit integer out of it. So let's see how we do this in an easy enough kind of way. Perhaps we need to do, or there are millions of ways we can solve this with, but I will choose this method because it's easy on my brain. So I will create another int16, which will be a pointer. That's right. And then I will simply do p is equal to the int16 representation of the buffer. I think this should be enough. Almost enough. We also need to dereference this, so we do this. this ret thing. Okay, it was a rather short episode today, but there will be a whole lot more of these spontaneous live streams. So yeah, that's basically it. If you like this video, please like and subscribe, and thanks for watching. Thanks for today.